Bismillahirrahmanirrahim and Assalamu alaikum. My name is Muhammad Harun Khan, and this is my video presentation for the case study I did in my electric machine course at Habib University Spring 2020. The topic for my case study was benefits of using variable frequency drives for starting and speed control of induction motor. The purpose of my case study is to provide a detailed analysis of one of the most integral power electronics technology, namely variable frequency drives, and to discuss how it is beneficial over other methods for starter and speed control of induction motors. It's important to understand that why do we even need starters. So what happens is that these induction motors deployed in industries are rated at extremely high power. What happens is that when these motors start to operate, they draw a huge amount of current, which is also called the inrush current. This current is severely harmful to the windings of the motor and hence can cause some serious damage to the motor. So we need some circuitry or such device or some methodologies that can help us to reduce this inrush current and hence enable us to operate the motor more safely. Some of the traditional starter methods for induction motor are direct online starter, star delta starter, and soft starter. The basic components of a direct online starter are a circuit breaker, a contactor, and an overload relay. What happens is that when the starting current consumed by the motor is overloaded such that it's above a certain threshold, then in such cases the overload relay of the direct online starter is activated, due to which the supply to the motor breaks and hence the motor comes at rest. This helps the motor to avoid damage due to excessive current. The benefits of direct online starters are it's simple, it's economical, it's suitable for small motors, and it's easy to operate, while the disadvantages are it's mechanically tough, it still consumes high starting current, and it causes a dip in the voltage, so it's not suitable for motors with high voltages. What happens in case of star delta starters is that when the motor is starting, the winding of the motor is changed from star to delta. This change in state of winding is possible due to the DP-DP switches. The advantages of this method are that the starting current is reduced to 1/3 of the current that was used in direct online starters, and secondly, it's inexpensive, while the disadvantages are the starting torque is also reduced to 1/3 of full load torque, and it can only work with some specific type of motors. In case of a soft starter, in between each phase of the input supply and the motor, a triac is incorporated. A triac is a powerful semiconductor device which consists of two thyristors. The advantage of having a triac here is that by applying pulse on the gate of a triac, we can control the current flowing through it. So with the help of a PWM generator, we can control through triac the current that is flowing from the supply to the induction motor, and hence by allowing the current to grow or to increase gradually, we can avoid the large inrush current that the motor would have to suffer otherwise. Conventional methods for speed control of induction motors are mechanical speed drives and hydraulic speed drives. Mechanical speed drives include gearboxes, belt drives, and chain drives. These all These all speed drive methodologies exhibit some similar characteristics in terms of performance. The drawbacks of these mechanical drives are that they produce a lot of noise pollution, they have poor response time, and bulky. While in case of hydraulic drives, they alter the speed by varying the inflow of fuel, which is oil or gas, in the coupling with the help of a valve. An increase in the inflow of fuel will cause the driving shaft to rotate faster, causing the shaft that is being driven to run faster too. This type of speed control is usually practiced in turbines. The drawbacks of these drivers are that they can be applied to only a limited kind of motors and can cause fuel leaks that can damage the overall system. A variable frequency drive consists of three basic sections. The first one is a rectifier, the second one is DC bus, and the third one is a rectifier. We will discuss each one individually. So the rectifier used in VFDs consists of a bridge made up of 6 diodes. These diodes, by working in collaboration, convert the incoming AC voltage into pulsating DC. The rectification taking place here is full wave rectification, and this rectifier is also called a full wave rectifier. Now, the issue with using diodes is that they can only provide you with a fixed voltage. So what you do is you replace the diodes in the same polyphase rectifier with silicon controlled rectifiers, which allow you to control the output voltage from 0 to a maximum value on the basis of a PWM signal applied to its gate. The second component of VFD is the DC bus. Once we acquire DC voltage with the help of a rectifier, this is not enough because this DC voltage consists of ripples. Hence, with the combination of capacitors, inductors, and chokes, these ripples are smoothed out in the DC bus. Another interesting feature that the DC bus performs is to maintain the power factor of the motor. The third component is the inverter. This inverter is responsible for converting the smooth DC output of the DC bus into required AC voltage. The inverter is made up of IGBTs, which are insulated bipolar junction transistors. The rationale behind using IGBTs is that they have really high switching speeds along with high voltage and current ratings. These IGBTs are controlled with the help of PWM signals that are fed with the help of a controller. Now, with the help of a PWM signal that is being fed into the converter, we can easily vary the speed and hence the frequency. The rate of switching of IGBTs determine the frequency of the output voltage, while the magnitude of time for which the IGBTs are on, or more precisely, the delay between the on and off, determines the magnitude of the output voltage, hence providing us a precise control over the speed of the motor. The table provided here is based on experimental results in case of an induction motor used for pumping of water in an industry. What happened was that different starter techniques were applied and their corresponding inrush currents were calculated. So as you can see from the table that VFDs appear to be the best in this case, as the inrush currents calculated for VFDs as starters was the least as compared to others. We know that in case of an induction motor, the torque is directly proportional to the flux in the air gap, which is directly proportional to the ratio between the voltage and frequency. Hence, by adjusting the frequency to speed ratio, we can certainly control the torque facilitated by the motor. The purpose of variable frequency device is to control the speed of AC motor with the help of varying the supplied frequency. The drive is also capable of maintaining the speed to frequency ratio as required in order to facilitate with enough torque. The advantages of using variable frequency drives for speed control of induction motors are that it causes energy efficiency and cost savings. Less inrush current is consumed by the motor. You obtain a precise control of speed and torque. Issue of low power factor at rated conditions is resolved, and it's a more convenient and robust method to control speed of the motor as compared to the traditional methods. There is a bright future for VFDs in the future market due to the unprecedented benefits it, they offer. Similarly, developments in the field of power electronics, FPGAs, and PWM generation can also lead to even more efficient devices. So, there are also possibilities of development of several add-on features that can make the use of VFDs further convenient to operate, such as remote monitoring and control of speed through IoT sensors, numerical keypad for setting of the speed, onboard controller, and many more depending upon the latest finding in the world of technology. After going through the analysis of VFDs based on detailed description of its components, functioning, and comparison, it is obvious now that in case of induction motors, the best and the most viable options for starters and speed control is variable frequency drive. Thank you so much for listening.